This is a tutorial on how to solve exponential word problems that includes two examples. Example 1. Leah put $10,000 in the bank. The interest on the money in the account is 3.5%. It is compounded each year. How long would it take for the money to double? The formula you would use to solve this problem would be A equals P multiplied by E raised to the power of R multiplied by T, where A is the amount after time, P is the initial amount, R is the rate, and T is the time in years. To begin solving the problem, you should look for any given amounts. We have the initial amount, P, which would be $10,000. We also have the rate, which would be 3.5%, but you will need to change this into decimal form for the problem. The rate will be 0.035. You need to find out how long it would take $10,000 to double at a rate of 3.5%. A now equals $20,000 because it is $10,000 doubled. Now plug the amounts into the equation. So now you need to find T. First, you need to divide both sides by 10,000. Now you need to plug in the natural log to both sides of the equation, which is ln, a button on your calculator. The natural log cancels out e in the equation. Now it's just normal order of operations. After you put this equation into your calculator, round your answer to the nearest tenth. Then you will see that 19.8 years is your answer for T. So it would take Leah 19.8 years to double her money at 3.5% interest. Keep in mind that Leah couldn't touch this money for 19.8 years, so that would kind of suck. But hey, this is a math problem, so it doesn't even matter. Example 2. The population in Ethiopia in 2005 was 20.2 million people, including Andy. In 2015, the population rose to 22.8 million people, including Andy. Using the same formula we used in the last problem, A equals P multiplied by E raised to the power of R multiplied by T, where T equals 5 because it's the year 2005, or 5 years into 2000. Predict the population in 2030. First, we need to find P, because we don't have the initial population, which is the population of Ethiopia in 2000. We need to plug in the amounts that we have. Now we need to get P by itself. Divide both sides by E raised to the power of 5 multiplied by R. So now that you have P, the initial population, you can find R. Instead of the population after time, A, being 20.2 million, it will now be 22.8 million, because that's the population in 2015. T will be 15 because now we are trying to find the rate using 2015. Now we can plug in our amounts into the formula. Since P is a fraction, it will make your life a lot easier by putting E raised to the power of 15 multiplied by R over 1. Then multiply these together. Since you have like terms in the numerator and denominator, you can subtract E raised to the power of 5 multiplied by R from E raised to the power of 15 multiplied by R. Now you will want to get E raised to the power of 10 multiplied by R by itself, so you will divide both sides by 20.2. Now that you have E raised to the power of 10 multiplied by R by itself, you can use the natural log, ln, on both sides of the equation. Apparently, the natural log and E will cancel each other out. Now you will want to get R by itself by dividing both sides by 10. Put this equation into your calculator, and you should find that R equals 0.012. Now you will want to go back to your initial population, 20.2 over E raised to the power of 5 multiplied by R, and plug in your answer for R. This is finding the initial population of 2000. Instead of our equation, 20.2 over E raised to the power of 5 multiplied by R that we found earlier. Now you will want to use the formula A equals P multiplied by E raised to the power of R multiplied by T, again to find the population in 2030. You don't have the population after time, but you do have the rate, the time in years, and the initial population. Plug all of these numbers into the formula. Now put this into your calculator and you will have found the predicted population of 2030. The predicted population in 2030 is 27.23 million Ethiopians, including Andy.